Now that we've explored the relationships between xt, vt, and at graphs, let's touch on another important concept in physics, the area under curve. Let's start with the constant velocity model, or CVM, where the velocity remains constant. This is represented by a horizontal line in the vt graph. The area under curve in this case is the area between the curve and the x-axis, represented by the orange rectangle. To find the area of this rectangle, we multiply its length, which is delta t, let's say 2 seconds, by its height, which is a constant velocity v of 5. In other words, the area is v times delta t. What does v times delta t represent? If we recall the definition of velocity, v equals to delta x over delta t. So v times delta t, or the area under curve, is actually delta x. Remember, you can call delta x the change of position or displacement. Now let's see what happens if the velocity increases. Imagine the velocity is now 10 instead of 5. So, the area under curve representing the change of position, delta x, becomes 10 times 2 equals to 20. You can see, with a higher velocity, the object travels a greater distance in the same amount of time. The area under curve, which represents displacement or change of position, increases as the velocity increases.